Okay, Assalamualaikum. Selamat sejahtera semua. So for experiment 4, it has the relation to chapter 5, states of matter. Experiment 4 is about Boyle's law, Charles' law. It is 5.1 in chapter 5. Okay, it has the relation to this one, kinetic molecular theory of gases. Okay, actually we have two types of gas. We have ideal gas, okay, and we also has real gas. Actually, we also has real gas. Okay, the gases that we have in our real life is actually behave like a real gas, but scientists uh, form an ideal gas where we have a few assumptions we make upon that gas, and we call it ideal gas. Okay, so ideal gas is actually doesn't exist. It's just the assumption that we have, that we make on that gas. We assume that there are no force and between gas particle, but in reality, in real gas, there are intermolecular force between two particles of gas. Okay, but we assume that there are no force. So to make our assumption, to make our calculation easier, we assume that there are no force and we call it ideal gas. And also we have another assumption regarding its volume. Okay, we assume that gas doesn't occupy any volume. If we have a container filled with gases, okay, when we want to calculate using PV equal to nRT, the volume used is the volume of the container. It's not actually the volume of gases. We assume that gases has no volume. So that is the difference between ideal and real gas. Okay. Uh, that one we will continue learning that in chapter 5. But for the sake of experiment 4, okay, these are a few characteristic of gas that we have to know. We should know. Okay, gas particle move in random motion. Gerakan zarah Brown, gerakan rawak kan. They constantly move in no particular direction. Okay, tiada arah yang specific. Okay, frequently collide with one another and the wall of container. Okay, collision antara zarah-zarah dan juga zarah dengan dinding bekas. Okay, this collision will give rise to pressure. Okay, inilah di mana datangnya tekanan from the collision. Okay, the collision between gas particle are perfectly elastic. This is in ideal gas punya assumption, but in reality the collision between gas particle are not elastic. Okay. Okay, so for ideal gas, we assume the collision is elastic. What is meant by elastic? It means that the kinetic energy of the gas particle before collision and after collision is the same. Okay, before collision, okay, then they collide. After the collision, okay, the energy of the gas particles are the same. Okay, the volume of the gas particle is negligible. Okay, kita assume yang gas particle tu tak ada volume. Okay, that's why gas particle is highly compressible. Okay, because in one container we have gas particle. Okay, the space between the gas particle is very far. Okay, we can compress, and we assume that if we compress banyak mana pun, dia lah, kita assume the volume of gas is not exist lah. Kita just take the volume of the container. Okay, the gas particle are much smaller than the space they occupy, so they are separated far enough. This make them highly compressible. Okay, the attractive and repulsive force between gas particle are negligible. Kita anggap no attractive and repulsive force between gas particle. Okay, and then we have Boyle's law, where we see the relation between the volume and the pressure. Okay, it is inversely proportional. If we have a higher volume, the pressure is decreased. Okay, when we compress, the volume decrease. The gas has high pressure. Okay, and then we have Charles' law, where we have direct proportion between the volume and the temperature. Volume and temperature are directly proportional. If we have high temperature, okay, the volume will expand, so we have the gas will expand, so the volume increase. When we put the gas in cold place, the gas particle will um, have low volume, directly proportional. Okay. Okay, the next one is Avogadro's law, where we have volume and number of mole of gases. Okay, it is directly proportional. If we have more number of gases, so the volume will be higher. Sebab banyak gas particle nak occupy, nak duduk kat situ, so kena guna lebih banyak space lah, volume lebih tinggi. Macam orang jugalah, kalau ramai orang, okay, tempat yang kita perlu sediakan tu lebih luas. Okay, for pre-lab, we have this simulator. Oh no, not this one.